Hello my dear students, in this lecture we are going to see introduction to the springs. Now basically spring is defined as elastic machine element which deflects under the action of load and returns to its original shape when load is removed. Means let us consider one spring. Let us say the spring is here, the spring is represented like this, right? And let us say on this spring, if I apply load is nothing but force. Now because of this force Ef, let us say without application of this force, before application of force, let us say this is the initial position of spring, and once I apply force, then spring will deflect from initial position to the final position, and this is called deflection. And my dear students, this spring deflects under the application of force, and whenever this force is removed, then again the spring will go to its initial shape and position, right? Such a member is called spring. So let us understand the important functions and applications of spring. Now in important functions and applications of spring, very first important or application of spring is that springs are used to absorb shocks and vibration. So here I will write springs are used to absorb, we can say, to absorb shocks and vibration. Now my dear students, whenever any machine is working, there will be a shocks and vibration in the machine. So for suspension purpose, springs are required. Therefore, for example, you can say suspension springs used in vehicles, right? In all automobiles, purpose of these suspension spring is to absorb shocks and vibration. Now second function or second application of spring is springs are used to store energy. These springs are used to store energy, right? Now the energy stored in the spring is called strain energy of that spring, right? Such as if I check the examples, then you can see springs used in clocks, toys, movie cameras. We can say springs in clocks, then toys, then movie cameras. These springs store the energy, and whenever required, they will use the stored energy. The clock is working because of the stored energy in the spring, as well as the toys are running. For small kids, we take spring toys. If I spring this, then toy will start running, right? Now third is springs are used to measure force. These springs are used to measure force, right? For measurement of force, the springs are used. You can see springs used in weighing balance and scales. Springs used in, we can say, weighing balance means weighing machine, and scales also. In scales, right, on scale there is a marking and there will be a spring. This is the purpose of spring, that is spring is used to measure the forces also. Again, there is one more important function of spring is that springs are used to apply force and control motion. Springs are used to apply force and control motion, right? Now this is very important purpose of spring. You can see in cam and follower example. In cam and follower, the springs used in cam and follower ensure that there will be always contact between cam and follower. Means the spring will apply force so that there will be definitely always contact between cam and follower. Again, in engine wall mechanism, valve, inlet wall and exhaust wall mechanism. Also my dear students, in engine wall mechanisms there is a spring used, right? There is a spring used. Again, in clutches, we have seen this clutch topic in previous lectures. We have seen this design of clutch and brakes, right? So in clutches, springs are used. Now the spring used in clutch ensure that the spring will supply required force for the engagement of clutch. Now once the application of spring is understood, let us understand the helical spring, because helical spring is most commonly used in all the machine applications. So my dear students, let us understand this helical spring. Now here, these helical springs, it is made from wire of circular cross section, right? It is, we can say, this helical spring is made from the wire of, is made from the wire of circular cross section, circular cross section, right? Now we will take one circular cross section wire, and from this wire we will make helical spring. And basically there are three types of helical spring. Now these three types of helical springs are, if the load applied is compression, then it will be helical compression spring, then it will be helical compression spring, helical compression spring. Second, if load applied is tensile, then it is helical extension spring, helical extension spring, extension spring. And if load applied is torsional, then it is helical torsional spring, helical torsional spring. So let us understand diagram of these three springs. Now here you can see the diagrams of helical compression spring. Now in case of helical compression spring, the load applied is compressive along the axis of spring, right? Again here you will see helical extension spring. For helical extension spring, the load applied is tensile along the axis of spring, right? And here there is a helical torsional spring. There is torque is applied. Torque is nothing but force into radius, right? Now my dear students, here this line, this line is called axis of spring, right? In case of helical torsional, helical extension and compression spring, this is called axis. These lines are axis of spring. And my dear students, for helical compression spring, the force is compressive. You can see the force P is compressive. For a helical extension spring, the force P is tensile, right? And my dear students, in both cases, that is in helical compression as well as in helical extension spring, though the force is along the axis of spring, but the stresses generated in wire, here this is a wire, here you can find this is a wire, from wire the spring is made. Now this wire will be having some diameter d, here this will be the diameter of wire, right? Let us say diameter of wire is d. Now because of this compression and tension, the stresses generated in wire, what I am saying, stresses generated in wire are torsional shear stresses, are torsional shear stresses, shear stresses, right? My dear students, don't get confused. Though the load is compressive or tensile, but in wire, I am not saying in spring. In the wire of spring, the stresses will be torsional and shear stresses. And whenever we apply compressive load, then there will be a decrease in dimension, that is change in length will be negative. There will be negative change in length, that is length will decrease. And whenever we apply tensile load, then there will be increase in length, that is change in length will be positive, positive change in length, right? And my dear students, again you can see in helical torsional spring. Now in case of helical torsional spring, the force is eccentric from the center of spring, right? Because of this eccentricity, we can say here eccentricity is r radius and force is at some eccentricity, right? Therefore the torque applied is equal to force into radius, right? And my dear students, here though the torque is applied on this helical spring, but in a wire, see here there is a wire, this is a wire of helical spring and a wire of cross section or diameter d, here diameter is d for this wire. Now my dear students, though the force applied is torque, but in this helical torsional spring the stresses generated are bending stresses. In the wire, I am saying in the cross section of wire, in wire the bending stresses will be generated, right? And my dear students, for gate examination we have to look at the helical compression and helical extension spring only. We will not concentrate on helical torsional spring. Now you might have seen this helical torsional spring in door hinges, automobile starters as well as door locks. You might have seen this helical torsional spring. And this helical compression and helical extension spring is generally used. You can see anywhere. Now next we will see multi-leaf spring. My dear students, this multi-leaf spring is also called leaf spring or laminated spring, or also called laminated spring, right? And my dear students, in this multi-leaf spring, it consists of series of semi-elliptical flat plates. It consists of semi-elliptical flat plates are used. Semi-elliptical flat plates are used in multi-leaf spring. Right. Now let us understand the construction of this multi-leaf spring. Now here in this say a leaf spring, you will find that there are multiple semi-elliptical flat plates. These are the semi-elliptical flat plates. Right. Now these semi-elliptical flat plates are called leaves. These are leaves. Right. Therefore, it is called leaf spring. And my dear students, the topmost semi-elliptical leaf is called master leaf. This is a, we can say this topmost is called master leaf. Master leaf. Right. And this master leaf is bent into the circle at the topmost point. These bends are called spring eyes. These bends, we can say, these are spring eyes. Spring eyes. Right. And my dear students, at these eyes location, there will be a force on the spring. As total 2p is coming downward, therefore 2p will go upward for equilibrium. Right. And all these springs are connected together with the help of U-bolt and center clip. Here you can find U-bolt and center clip. These clips will connect all these leaves together, right? And such type of spring is called multi-leaf spring. Many times in automobiles you might have seen such type of spring. Now, example, such type of springs are widely used in automobiles. Widely used in automobiles, right? And railroad suspension as well as railroad suspension. This is the use of these multi-leaf spring. Thank you, dear students. In next lecture, we will see terminology of helical spring.